Did all of them match what their description said?
Yes, sir.
I'm seeing one that had a traceback error. What happened there?
Where?
You can't see the one that's there that has an error.
Oh, for this one. I don't know. I
Yeah,
kept repeating it, but I kept saying it was. Wait.
invalid invalid format string. You didn't notice it.
No, I did. I don't know why. Yeah, I don't know why it showed error.
Okay. If you when you check your WhatsApp, what does that format stand for? What does that 53 stand for?
Let me see. Uh,
Or what does the capital S stand for?
it stands for. Oh, I made a mistake. There was no small letter S.
Okay, it's only capital letter
That's
S.
what
So what does
happened
the
there.
capital letter S stand for?
Second.
Okay, seconds. Okay. All right. The one for Z did not show anything.
Yes, I don't know. Yes, Z didn't show anything.
Okay, I scroll down. Let me see the one that came after that. Yeah, I can see another trace back. What happened in that one?
For which one? This one.
Yes. What happened there?
Oh, the other one. I put it.
I
Eh?
think it's because, can you see that percentage sign? Are you supposed to
Yes.
have two percentage signs at a particular time? That may be the
Oh,
reason why.
yeah. I
So
think
that's
yeah,
probably
it is.
what caused it.
Yes.
Mm. Okay. Okay. So um, let me see. All right. So I think we'll continue from where we stopped. Um, do you remember the things we did in the when we started with the maths module?
Yeah,
Do you
we did
remember?
about like power and stuff.
Power and what?
Power, square root.
Square root, exactly. We did power. Power did not need the math module to be imported, right? Power and absolute value, and then minimum and maximum. Those ones
Yeah,
they did not need any importation of the math module. But the ones that we did for square root needed importation of the math module. Now, this one that I'm sending you now, it also needs importation of the math module. So I'm going to send it to you, but then you will have to import the math module by yourself. You remember how to do that, right?
yes, sir.
Okay. So just, okay. Can this file is no longer active now.
Yes, it
So you
isn't.
can't you can't reuse it. So we have to do a new one. Okay. So okay, so I'm going to send you something in the chat box now. So remember, import the math module first before you paste anything you see.
Also, is it import data the date time?
Math. We're done with date time now. This one is math. M-A-T-H. Not
Okay.
math, so math, singular. I'm sure those two functions look familiar, right?
Yes, sir.
Okay. So quickly, can you explain why the first one returns 2? The one that has x, the variable x on the left-hand side, and then on the left-hand side of the assignment operator, and then the one that has y, or the second one that has y on the left-hand side of the assignment operator returns 1. Can you explain why?
Is it because like the first one is like rounding up.
Rounding up.
Yes, sir.
And the second one is like what?
Rounding down.
Rounding down. Hmm.
Yes, sir.
That's an interesting way to explain it. Anyway, I'm just going to annotate something. So 1.4, right? 1.4, you can say that 1.4 is somewhere between 1 and 2, isn't it?
Yes,
It's
sir.
between 1.0 or one whole number and what? 2.0,
Um,
isn't it?
yes, sir.
Okay. So what you call rounding up is the one that matches the ceiling. Okay, you know, ceiling is usually something that is on top, right?
Yes, sir.
So that's why 2.2 is going to match that one that says mat.seal. Seal is short for ceiling, like roof. Okay. Then 1.0 matches the one that's down. So that's the floor. So because floor is usually at the bottom, isn't it?
Yes, sir.
So that's why this one is down. So that's what you're calling rounding down. And then this ceiling is the one that you call rounding up. So I believe this one is familiar to you, right?
Yes, sir.
Now, do you remember what happens whenever you do hashtag in Python? What is that? What happens there? What happens whenever you do hashtag? Hmm?
Um, uh,
Hmm? You've forgotten.
yes, sir.
Hashtag is comment now. That's the reason why they are standing there in red. They're not doing anything. So do you understand? Python just simply
Okay,
ignores
okay.
them. It's like giving you more information about that line. So for instance, before you see that it returns 2, it will tell you what it will return, isn't it?
Yes, sir.
The second one, it says returns 1. In other words, the answer is 1. That means the content of the variable y is what? 1. So that's
One.
just basically what the comments are doing. So remember what comments do. Comments somehow help us to explain our programs, give more information about any line that may be confusing, not like in this case. It's not like it's confusing in this case. But now somebody who is seeing this for the very first time will know, okay, okay, so this thing is expected to return 2, and this thing is expected to return 1. If it returns anything other than that, where it's up for questioning. We'll have to get to the root of it to find out why it doesn't do what the comment says it should do. And the writer of the program make a mistake, some things like that. Those are the uses of comments. Okay.
It is.
Um, that's for ceiling and floor. Now, just this one is just, I know that this one will be more like a reminder. Um, Tell me what you think you will see if this thing executes. Now, that means you are going to copy and paste it, but do not run it. Do not hit enter after the print statement until you can guess what value we show. Have you seen what I sent?
Yes.
So do you remember what's the value for pi? Don't hit enter yet. What's the value for pi? The simplest value that you know in mathematics. Do you know about pi?
Yeah. Three.
Uh-huh. Yes.
Three. Do I have to say everything?
Just give me the first 3 decimal places or something.
3.14.
3.14. That's two
Yes,
decimal
sir.
places. More like 3.142. That's usually the one that you would see most people give. Hit enter. Let's see what this one will show us. It should give us something
Yes,
more
sir.
than
3.1415926 five
so.
three five eight nine seven nine three.
Now it's quite interesting that even these numbers on another computer, it may show something different. And you might be wondering why. It's because sometimes this is pi. They call this kind of numbers irrational numbers. Not that they're irrational in the English, in the sense of the English word, but because you cannot really write them as a ratio. So in mathematics, they usually tell us that pi is 22/7, but that 22/7 is the closest approximation that will enable us to treat pi as a fraction or as a ratio. But in the true sense, pi is not a rational number. It's not a number you can express as a ratio. That's what that um, this thing suggests. So another computer, you may not see it as 1.1415. It will not be exactly the same set of numbers, but it will not, the thing that you're sure of is that you will see 3.14, at least that one is sure. Maybe you see 1 after the 4. The things that come after that, maybe the 5, and after the 5, it may be slightly different. But the important thing is that at least we have something we can work with. Do you understand what I'm saying?
Yes, sir.
Okay. So pi should not be strange to you. I mean, you must have learned it in school, and then they probably remember, if you can remember when we did it in what do you call it? Um, in Java script. Um,
Yes, okay, sir.
okay. All right. So us to move to another math expression. Now that place where you have math dot pi, can you do x? Let's see some other things that may be under math, some other functions that may be under math. Can just do x assignment operator math dot. Okay, let's see some other things that may be under it. Okay, so we have time.
Akosh, Asin.
Yes, yes. That A in front of the cos. It's actually arc, saying opposite the arc function of cosine. All those ones, you may not need them. They are specialized, what do you call it? Functions that maybe it's people that who are into engineering self that may even really need it. Okay, use your down arrow and just be moving down. Don't move down too fast. Your down arrow so that we can. Is that your down arrow that you're using? Your that
Yes.
arrow, that your arrow that is pointing down. That's what I mean.
It's not working. I'm using it. It's not working.
Oh, okay. Let's try the up one. Let's see.
But
Okay. All right. Try it again. Let's see.
okay, it's working.
Uh, okay. All right. Keep going like that. Let's see if we see anyone that's familiar. Keep going.
Okay, sir.
CBRT. Keep.
See
No,
you.
we've seen stealing. Yes, we've done stealing. Keep going. I don't know what that comb is. That comb. I hope it's not combination. Okay. These things are specialized functions, so but okay. Keep going. Now, some of them are functions, some of them are constants. That E is a constant, for instance, that E there. But keep going. Let's see.
I've already
Okay,
done floor.
factorial. Good. Good. Look at factorial. Go to factorial. Let's talk about factorial. Yes. Okay. Yeah. Okay. So now put any number you want in factorial, but a number that is less than 10. Any number you want.
Okay.
Between zero and 9. 2. Can you put something bigger than 2? I want to see if I can explain it better. Then you can now be using any small number that you like. Okay, so 5. All right, so let me see if I can use 5. So now factorial in maths looks something like this. 5 with an exclamation mark. Okay. So for instance, now 5 factorial is given by this. It's equal to 5 times 4. So you see what is happening. I'm just reducing it by 1 times 3 times 2 times 1. Okay. Did you get that?
Yes, sir.
Okay. So now let's multiply it. Don't hit enter yet. Too. When we multiply it, we'll check if that one agrees with our answer. 5 times 4 is what?
20. 7.
20. 20 times 3 is what?
60.
60. 60 times 2 is what?
120.
120. Of course, we know that anything times 1 is 1. So the answer is 120. So go ahead and hit enter. Let's see whether now print X. Okay. So you can see,
120.
yes, 120. So it agrees with our, what do you call it? It agrees with our calculation. Now, you can try any number you like. You can try 2, you can try 1, you can try 0, because some of them are quite interesting. You can try any number that you want.
Just shows 1.
Yes, because after 1, you understand, if you reduce 1 by 1, it's 0. So go ahead. So are you wondering why 1 factorial is not 0?
Yes.
So some of those factorials, they have constants. So you cannot even explain them. They are mathematically fixed. So you
1.
can see that even 0 factorial is 1. Did you see that?
Yes, sir.
Uh-huh. So of course you have factorial for big numbers. Yeah. Okay. So that's factorial for you. Now you might be wondering, where do we need factorial in? I don't know if you guys do additional maths in school. Do you do additional maths?
No.
No. Okay. Well, it's just good to have it handy. You might just need to write a program that will help somebody with automate their factorial calculations. So if that happens, then you can use this function in a handy manner. Okay. All right. So where did we? So you remember what you did back then? Just do that X assignment operator math dot. Then we'll look for any other thing that's familiar to us.
Yes, sir.
Okay, hold on. After factorial is floor. We've done that one. Okay, keep going. F sum. No, I don't think we need that. GCD. Hold on, slow down. Is finite. Okay, keep going. Okay, I saw something. That's in LCM. That thing looks like LCM. After
Yes. Yes. It
and
is.
you do you know do you have an idea what this one might be? I square root. Do you have an idea what it might be?
No.
Go ahead and try it now. Go ahead and give it a try. So you know that time that we use square root in the last class, it will give us a float number, a number that has decimal point all the time. So most likely this one will always give us an integer. So go ahead and try. Find the square root. We'll do square root of 64, then do square root of 3, like we did in that last class. So go ahead, put 64 in between the parentheses, and then print your x. Then we'll try. Okay, so you can
Yes.
see it's an integer. So try square root of something like 3. We know square root of 3 is not a whole number. It has something like 1.14 something. So try it out.
Oh, sorry.
Change that. Remember to change the 64 to 3. Already
Oh,
hit enter. Okay, okay, uh-huh. Okay, okay.
one.
Can you see what it did? So it truncates. It doesn't even round up or round down. It does not round up anything. It just cuts off the decimal point completely. Did you notice that?
Yes, sir.
So I square root or I sqrt is not good for situations where you need precision. Precision just simply means you are interested in all the decimal places. You don't want to leave anything out. You understand? You see that value of pi now. Just imagine us trying to cut off the 1.1415926, blah, 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 all that. Imagine cutting all that off and just calling pi 3. How do you think it will look? It's for some mathematicians, that would be a serious assault on their field. That would be like saying pi has changed. Uh-huh. Now, does it mean that there are no situations where you may need an integer format? There are times when nobody's interested in the decimal part. In that scenario, this one will come to um, help in that case. Okay, okay. So let's try that LCM one. Let's see how it works. Let's see um how it
Yes,
will.
sir. Sir,
Yes.
can I go to toilet after this?
Uh, okay.
What should I
Okay.
put in the middle of it? Oh, sorry.
Open the parenthesis now.
Mistake.
Uh, okay, so can you see that star there, that asterisk? It's expecting you to put some numbers in between. So
So,
lowest common multiple. Now put numbers that you know their lowest common multiple. Oh. So you're putting 12. I think you should put something like 3, 3. Okay, you're putting 12 and 3. Okay, let's see. Hit enter and print X.
12.
Okay, so that's the lowest common multiple they have in common. I think that's actually it. So you can see how they put the argument there. They just put asterisk. Remember, asterisk means something can be repeated. It can be more than one. Okay, 1, 2, 3, 4, 5, 10. 10 numbers. You can find the lowest common multiple of 10 numbers as you wish. So this one is not fixed. Okay, so quickly go use the restroom and come back.
Yes, sir.
So any questions on the ones we've done so far?
No, sir.
Okay. All right, let's see if we can discover some other ones. So do the same thing, X assignment operator, math dot, and then we'll keep going down with the arrow key. Okay. So let's see some. Okay, hold on, slow down. Slow down. Have you okay, that's LCM. Okay. Logarithm. Okay. Um okay. Okay, uh, let's do that log 10. That one that has log 10. I may not say too much about it, but let's just do that one. Log 10. Have you seen it? Okay. It also, I think it should only take one number. Returns the base 10 logarithm of x. Now, let me explain logarithm. Hold on. Don't just put any number you like. Oh. Let me explain it. Please just listen. You see, it's something that you benefit from. Okay. So, logarithm, where do I start? Okay, let me just start. I'll just do something simple. It's not a math class, right? But if you can understand this, I bet you wouldn't have any problem with logarithm in whenever you see it later in life. Okay, so 10 raised to power 3 is what? Please don't come and tell me 30 like you did last time. 10 raised to power 3 is what?
1,000.
Thank you, 1,000. Okay, so now I want you to look very carefully at what I'm doing, right? 1,000. Now, logarithm is just another way of rewriting this thing that I just wrote. Just understand it like that. It's just I don't know how to say it, but it's just a different way. Some mathematicians came up with a different way of doing things. All right. So in most books, if you look at most books, I don't know which class they will teach you this thing, but usually indices, whenever they teach you indices, they teach indices alongside logarithm. Shalom may understand what I'm talking about, but um, this what I just wrote down here that you can see here is indices. Indices is plural for the word index. Have you heard this word index before?
Like in maths.
Yes, in math. Have you heard the word index before in math?
No, sir.
I know the only place you remember index is in when we were talking about lists, right?
Yes, sir.
That's position. But the truth is that it's not even different self because index two has it's usually integers. Usually integers. It's usually a whole number. Now let me just explain it. Can you see this three here? This power that is here, the three. Hmm?
Yes, sir.
That tree is called a power or an index. Okay, I'll give you all the names. Okay, it's called a power. Okay, just like that, just like what you said now, 10 raised to power 3. Is that not how we said it?
Yes, sir.
Uh-huh. Please take note. Oh. Are you even with your notebook at all?
No, sir.
Eh? No.
No,
Well
sir.
done. You will come to class without notebook. I don't know how you want to take note of things, new things that you learned. Eh? Another name for that small tree that you wrote up there is power or index. Okay, so when you write an expression like this, 10 raised to power 3 it falls under the part of maths that we call indices. Okay, things that have to do with powers and all that. Now, I want you to just look. Oh, logarithm is just another way of writing indices. Let me just put it that way. Now, see what I'm going to write. So log, the name log, L-O-G, is short for logarithm. So see how I'm going to write this thing that we just wrote now using logarithm. I'm going to say the log or power, okay? The log or power of 1,000. Now I know you're wondering, but I thought the power is on 10. The power is on 10, but the logarithm belongs to who? 1,000, okay?
Yes, sir.
Are you with me? Okay,
Yes,
just
sir.
what I'll try not to make it complicated. The logarithm of 1,000 to the base 10, okay, to the base 10 is equal to 3. If you can understand this thing, I promise you, whenever they introduce it in your life, anytime they introduce it anywhere in your schooling or anywhere you see it again, you never forget it. Okay, so let me say it again. Logarithm of 1,000 to the base. The base is, you see that 10 that you are writing big before, this 10 is called the base. It's called the base. That's another name for it. Okay, it's called the base.
Yes, sir.
Why is it called base? It's called base because it's written down at the bottom. Why the 3, the power, is written on top. Okay, so base sounds like something that's at the bottom, isn't it?
Yes, sir.
Uh-huh. So if you can remember this thing, you don't have any problem. So the logarithm of 1,000 to base 10 is what? 3. Now, I'm going to write this one. I want you to tell me what the logarithm will be. Okay. So I think it was in the last class. No, it was not in the last class. Let me um, do something that we used in the last class. I asked you 3 squared, isn't it? 3 raised to power 2 is what?
No.
Thank you, 9. Okay, so now if you wanted to write these indices as a logarithm, what will it be? Just tell me what it is, what you think it will be.
Wait.
Just based on this explanation I gave now.
Yes.
Yes.
Isn't 9?
No, start it, read it the way I read it. See the way I read this one. Logarithm of 1,000 to base 10 equals 3. So how would this one's own read? Yes?
We can repeat it. Okay. How do you just said now?
Eh?
Can you repeat what you just said now?
Logarithm of 1000 to base 10 equals 3.
Yes.
So how will it be for this one that's 3 squared equals 9?
This good.
Just look at the position now. The 9 is on the same side with 1000. The 3 is on the same side with 10. The 2 is on the same side with 3. It's a simple thing, simple concept. Is it you still don't understand it?
Yes.
Ah, okay. I'll leave it for your math teacher. Whenever your math teacher wants to teach you, people will learn that one together. Logarithm of 9 to base 3.
Sir, I'm in year
Yes.
7. This is like what they teach to year 9.
So if I give you a snippet of what you will learn in year 9, is there any problem with that?
But
Hmm?
it will be
It's
confusing.
just, it will be confusing. Really? Okay. No wahala. Let's see how it will look like in our program. So in this program now, that place where you have log 10, in between the parentheses, put 1000 there. Put 1000, 1000. Then hit enter and print X. Okay, so what did you notice?
Just 3.
It's actually 3, isn't it? And you can see it agrees with our concept. I just said I should just show you this, but anyway, since you don't understand it, you can safely ignore it. Whenever they teach you in year 9, God will help you to understand it. Oh yeah, do the X assignment operator math dots, and let's see if there's any other familiar one or any interesting one that I can show you. Just type your X assignment operator math dot. Yeah. Yeah. Okay. Yeah. Okay. 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 Is that the last one?
Yeah.
That prod, what do you think that prod is? Product. Do you think it's product?
Yes, sir.
You think it's product?
Yes.
Okay. Okay. That's quite interesting. Okay. Okay, so let's try it. We'll try that prod, and then that one that you are on, remainder. Remainder should be modulus, but we'll try two of them. So try that prod, PROD. Let's see what it will show us, what it will allow us to do. Product of stuff. Okay. Open the parentheses. Let's see what it will show. Does it have anything like asterisk? Oh, iterable. Okay, so sorry, hold on. No. Let me remove this thing. Calculate the product. Oh boy. Okay. Calculate the product of all the elements in the input iterable. Oh, okay. All right. So now what this thing is going to do is, okay. Um, hmm, hmm. This one, I think this one will need us to create a list. So it's not just integers. All right. So back up. Go for that remainder. We'll do it another day, not today. Remainder. Okay. So that one is clearly division. The difference between x and the closest integer multiple of y. Okay, so you remember how we can find remainder, right?
Yeah.
Remainder after division. So which one can we quickly try that we know it off? We know the answer offhand. 10 modulus 3, right? If we divide 10 by 3, there will be a remainder, isn't it?
Yes, sir.
What remainder will be there?
3.2. No.
Did you just say 0.2? I said remainder. If you divide 10 by
Oh,
3,
remember one. Remember one.
thank you. So put 10 there, 10 comma 3. Let's see if it will give us 1 as our answer in x. Print x. Let's see what it will show. Okay. Okay, so it's exactly is correct. Okay. All right. So I think we can safely stop here for today. I don't really have much power on my device. But do you have any question?
No, sir.
Okay. All right. So I'll send you something to do along these lines. Maybe we'll do a match. We'll have a match statement in the mix, match case statement in the mix, so that it will be an interesting program to work on. All right. So I guess we'll meet on Tuesday.
Yes, sir.
Okay. So remember to thank Sharon. I don't know. She left you with her phone. She allowed you to use her phone today.
No, I'm using my phone.
You're using your phone, but you are chatting. The phone you were chatting with me was not your phone now.
No, because my phone was dead.
Okay. That's what I was saying. The same thing now. She allowed you to use her phone, isn't it?
No, I'm chatting on a laptop.
Oh, I see. Okay. Okay. Anyway, still appreciate her for the laptop. What did I want to say? Um, yeah,
What should I
you
say
are
else?
asking for your website. Why were you asking for your website?
Because my dad wanted to know what we're doing. He want,
Oh,
he want, he wanted.
but,
He asked
but
me.
that website is JavaScript now.
Yes, he wanted to. Because he asked for what is the app that we've made. So I was asking for the one that we did in Python. I mean JavaScript.
Oh, okay. Okay. Well, if we want to do something like that for Python, it means that we'll have to take screenshots. I mean, it will just be like displaying programs, but I don't think that's necessary. So um, if he really wants to see it, then you can show him these files um, that we work on and save. Yeah. Using you is that how you spell using? There's no E now.
I saw
Anyway, don't
something.
worry. Don't worry, just leave it. It's fine. Don't fine, it's fine. But that kind of mistake, don't be making that kind of mistake.
So,
Okay. All right. So we'll meet on Tuesday.
yes, sir.
Please do your
Bye, sir.
best to be on time so that it will
Yes, sir.
save us to start on time and end on time. Is that okay?
Yes, sir.
When are you guys closing for the term?
This month.
Huh?
I think like on the 20th.
On the 20th. Okay. All right. No problem. See you on Tuesday.
Thank you, sir. Bye, sir.
Bye.